Hey kids, welcome to section 2.2, histograms, frequency polygons, and ogives. Today we're going to learn how to represent data in frequency distributions graphically using histograms, frequency polygons, and ogives. All right. So the purpose of graphs in statistics is to convey the data to the viewers in a pictorial form. The three most commonly used graphs in research are the histogram, the frequency polygon, and the cumulative frequency graph, otherwise known as the ogive. And so this blue table right here is like a recipe that you can look back on later when you're confused or you don't remember what to do. Step 1, we're going to draw and label the x and y axes. Step 2, on the x-axis, we're going to label class boundaries of the frequency distribution for the histogram and the ogive, but we're going to label the midpoints for the frequency polygon. Step number 3, we're going to plot the frequencies for each class and draw vertical bars for the histogram and the lines for the frequency polygon and ogive. So we have bars for the histogram and we have lines for the frequency polygon and ogive. Also remember that the lines for the frequency polygon begin and end on the x-axis, while the lines for the ogive begin on the x-axis. So this table right here is a very good summary for what I'm about to show you. So the first thing is called a histogram. It's a graph that displays the data by using contiguous vertical bars. By the way, contiguous means touching. Unless the frequency of a class is 0, and then we just have a blank spot. And we use of various heights to represent the frequencies of the classes. So for instance, these data represent the record high temperatures in degrees Fahrenheit for each of the 50 states. Construct a histogram to represent the data shown for the record high temperatures for each of the 50 states. So this is the same problem from section 2.1. Here is the 50 raw data values. And we, during the last lecture, drew this frequency table. And so we're going to use this to draw a histogram. So remember that a histogram needs two things. It needs class boundaries, and then frequency is on the vertical. So we're going to draw as straight a line as possible down and as straight a line as possible over. We're going to put class boundaries along the horizontal. I need 1 at the start, 99.5, and I need 1 at the end. So that's 1, 2, 3, 4, 5, 6, 7, 8 marks. 1, 2, 3, 4, 5, 6, 7, 8. So we can go ahead and write them in. So we have 99.5, and then 104.5, 109.5. I might skip one, put 119.5, 129.5. Then I need to have a high frequency of 18, so maybe I count by 2s. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So these down here were temperature. And these along the side were frequency. Okay, so our first one is a height of 2. So I'm going to go up and over. And then the next one is 8. So you basically want to try to get the bars as evenly as possible. You don't want one bar to be extremely fat while another bar is really skinny. 13 goes like this, and then 7, and then 1 and 1. All right, so obviously trying to make them as straight as possible, as evenly widthed as possible. That's a histogram. So we can see lots of stuff from this. We can see how it has a nice even increase and a nice even decrease. We can see that there's one high peak, those types of things. All right. The next type of graph we're going to look at is called a frequency polygon. This is a graph that displays the data by using lines that connect points plotted for the frequencies at the midpoints of the classes. The frequencies are represented by the heights of the points. All right, so again, we have these 50 record high temperatures in degrees Fahrenheit, and here is the frequency distribution. From this, we need to draw our frequency polygon. However, along the horizontal goes the midpoints. So I need to find the midpoints of my classes so that I can graph it. So I'm going to put midpoints over here, and I'm just going to make another column. So to find the midpoint of the first class, you need to find the number that's exactly in the middle. Well, to do that, that's the average. So you can take the two numbers, add them together, and divide by 2, and you get 102. And you can add the next two classes together and divide by 2, and you get 107. Ooh, notice that's a difference of 5. Oh, I bet you we could keep going and get 112 and 117, 122, 127, 132. That looks about right. Work smarter, not harder. Okay, so these are the numbers that are going to go along the bottom. There's one thing to remember. I need to add an extra midpoint before, and I need to add an extra midpoint after, because my frequency polygon has to start and stop on the x-axis. So one more before and one more after. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 marks. First one is 97, so I'm going to just label all the 07s. 127, 137. And these are temperatures. Then I need frequencies going up. We have to get to a high of 18. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. These are frequency. Now, the frequency polygon has to start and stop on the x-axis. So that's what those first and last dots are for. And then above each midpoint, you're going to graph the frequency. So midpoint of 102 goes with a frequency of 2. 107 goes with a frequency of 8. 112 goes with a frequency of 18. 117 goes with a frequency of 13. 122 goes with 7. 127 goes with 1. And 132 goes with 1. Now you connect the dots with straight lines. Try not to curve it. It's very tempting to want to curve it. Ooh, that was a bad one. So try to make the lines as straight as possible. That's called a frequency polygon. It starts and stops at the x-axis using midpoints. All right, third and final one is called the ogive. The ogive. Sometimes this is called a cumulative frequency graph. The ogive is a graph that represents the cumulative frequency for the classes in a frequency distribution. So we need to do cumulative frequencies on the or on the XY, and I need to do boundaries along the bottom, just like the histogram. So class boundaries, 99.5. So there was 7. 1, 2, 3, 4, 5, 6, 7. Yeah. 1, 2, 3, 4, 5, 6, 7. So we got 99.5, 109.5, 119.5, 129.5. I must have missed one. And then one more. And then cumulative frequencies are going to go on the vertical. We need to find those cumulative frequencies. So I'm going to put cumulative frequency. So what we're going to do is the first one is always 0. Because there are, remember, cumulative frequency is all the values that are less than that value. So the first midpoint is 99.5. There are no numbers smaller than 99.5. Then we add the next number in the frequency column, 2. So 0 plus 2 is 2. Then we add the next number, which is an 8, to get 10. Add the next number, 18, to get 28. The next number, 13, to get 41. The next number, 7, to get 48. The next number, 1, to get 49. And the next number, 1, to get 50. This number here, the final number 50, should equal the number of values in the data set. All right, so now we can put the cumulative frequencies. We have to get up to 50. So 5, 10 maybe, 15, 20, 30, 40, 45, 50. Okay, so along the bottom, again, are temperatures. And then we have cumulative frequency. So we start at 0. Then the next one is 2. Then 10. 28. 41. 48. 49. 50. And then connect them with as straight a lines as possible. So this is called an ogive, or a cumulative frequency distribution, cumulative frequency graph. The point of it is to be able to visually see that the majority of the numbers are going to be below in the bottom half. That's because it took a while to increase. And notice that the slope of the line up here is a lot smaller, which means the growth was happening a lot less, which means there weren't as many numbers. So the cumulative graph can tell you right away how many numbers were less than a specific value. So to recap, the histogram, the frequency polygon, and the ogive shown previously were constructed by using frequencies in terms of the raw data. These distributions can be converted to distributions using proportions instead of raw data as frequencies. These types of graphs are called relative frequency graphs. And graphs of relative frequencies instead of frequencies are used when the proportion of data values that fall into a given class is more important than the actual number of values that fall into that class. So, you know, if you tell me that there are 4 people sick in the senior class at DHS, well, I don't know what amount of people that 4 was taken out of. But if you were to tell me that 4% of the DHS senior class was sick, that would make a little bit more sense. To convert a frequency into a proportion or relative frequency, you divide the frequency for each class by the total of the frequencies. And the sum of the relative frequencies will always be 0. Due to rounding, it might be 99 or it might be 1.01. However, it should always be relatively close to that. Now, when you're describing the data, it's important to be able to recognize the different shapes of the distribution values. So here's some of the more common shapes for distributions. The first one is pretty popular. It's called a bell-shaped distribution. It has a single peak and it tapers off at either end. It's also approximately symmetric. So it kind of looks like this. Tapers off at the ends, and it's relatively a reflection of itself. A uniform distribution is basically flat or rectangular. For these, your distribution just looks like a rectangle. It's really boring, and it basically means that no matter what different value for shoe size you have, the frequency is always the same. There's something called a J-shaped distribution, and that's when you have few data values on the left side and it increases and one moves to the right. So we have a distribution that kind of looks like that. So here's your kind of J shape. A reverse J-shaped distribution is the opposite of the J shape. So we're starting up at the top and we're going down to not very many. Now, here's a really popular way to describe data. When the peak of a distribution is to the left and the data values taper off to the right, the distribution is said to be positively or right skewed. So it'll look like this. Sometimes we call this end the tail. And so if you notice, a right skewed distribution has a longer right tail. And so it always goes to the tail. The other way is called left skewed. When the data values are clustered to the right and taper off to the left, a distribution is said to be negatively or left skewed. So if I have tapering and then up like that, that's called left skewed, mostly because there's a tail here on the left. Distributions with one peak are said to be unimodal. So this very first one that I drew here is a symmetric bell curve, and it's unimodal. So we could just put unimodal. Oh, that's pretty bad. It should go down farther. You get the idea. Okay, now I made it worse. The last one, when a distribution has two peaks of the same height, it's said to be bimodal. So if I graph it and it looks like this, that's bimodal. So these are different ways that you can describe a distribution. All right, so here's an example of putting all of this together. Assume you are a realtor in Bradenton, Florida. You have recently obtained a listing of the selling prices of the homes that have sold in the area in the last 6 months. You wish to organize those data so you will be able to provide potential buyers with useful information. Use the following data to create a histogram, frequency polygon, and a cumulative frequency polygon. Use relative frequencies. Make sure that this is on your paper. Use relative frequencies, because I did forget it once. Okay, so this page is mostly to be used for the frequency distribution. And then the next slide is blank. We're going to use that to draw the graphs. So first we need to come up with the classes. So we need the maximum, we need the minimum, we need the range, and that will help us find the width. So the maximum value in the table is 321,550. and the minimum value is 67,900. That gives us a width of 253,650. Let's see, I want 7 classes. So if I divide by 7, that's going to give me, well, it's some weird number with 5 different numbers in it. I'm just going to make it be pretty and say 40,000. Now let's do 50,000. It really doesn't make a difference what you call your class width, as long as you're making every value be able to be found in your distribution. So usually we would start with the class limits and the boundaries and the frequency. I'm going to leave the tally out. You can put the tally column in there if you really want to, or we could just count. Okay, so I'm looking at the class limits. Now the smallest one is what we usually would start with, 67,900, but that's kind of an awkward number to add 50,000 to. So let's just call it 50,000 to 100. Well, we can't do the second part yet. We got to the next lower. So 50,000, then 100,000, then 150,000, 200,000, 250,000, 300,000, and 350 would be our max. So yeah, we don't need to do any of that. So it looks like I have 6 classes, but that's okay. So then my upper limit would be 99,999, 149,999, 199,999, 249,999, 299,999. This is fun. And then 349,999. I think my numbers got bigger. Okay, class boundaries. Let's see. We want to close the gap, so we're 0.5ing. So 0.5ing back, 49,999.5 to 99,999.5. Maybe we'll just keep putting the boundaries. So let's see, so 99, so 149,999.5, 199,999.5, 249,999, 299,999.5, 349,999.5. Okay, in terms of frequency, after you do your tallies, you get 16, 18, 11, 3, 0, and 1. All right, so to save space and time, I didn't put all of the boundaries in here, but I did put the ones that we needed. Okay, now let's take this information. Take this information and we're going to draw a histogram and a frequency polygon and an ogive. All right, so let's do the histogram first. So the histogram, I'm just going to draw it on here because why not? On a histogram, you need the class boundaries along the bottom. So the class boundaries started at 49, and there was 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. This first one is 49. I'm trying to write sideways. Oh, oh. 40. Okay, that's not working. I'm trying to write sideways. It's not working. 49.9.5. Oh, this is not going to work. And then 149. 9.5 and 249 9.5 and 349 9.5. Then the totals from the previous slide, I'll just put them over here. It was 16, 18, 11, 3, 0, and 1. These are dollars along the bottom. And then frequencies, we got to go to 18. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. This is frequency. Ooh, we got to do relative frequencies. Let's go back up to that previous slide. It says to do relative frequencies. So we got to add an extra column over here. Relative frequency. So remember, there's supposed to be 50 altogether. So let's see, 16, 18 is 34, 40, 34, 35, 36, 37, 33. Oh, there's only 49. My bad. There are only 49. Yes. Because there's 7 down and 7 across. So we're going to take each of these values and divide it by 49. And then we're going to put our relative frequency. 2 decimals is totally good. So 16 divided by 49, if we put it, is going to be 0.33. This is 16 over 49. Then we have 18 over 49. That's going to be 0. Oh, wait, hold on. I said that. This number's wrong. I thought that was not right. 0.33. Sorry, that was right. 18 over 49 is 0.37. So it's 37%. The frequency of 11 goes with a relative frequency of 0.22. 3 goes with a relative frequency of 0.06. Obviously, that's 0. And then 1 goes with 0.02. Remember, the total of all these should be somewhere around 1. So 33 and 37 is 70, 92, 98, 1. So we're good. So the relative frequencies are what we want to put along the vertical. So let's get rid of these. Okay. So those relative frequencies were 0.33, 0.37, 0.22, 0.060, and 0.02. So along the vertical, let's just draw it. Got to get up to 37. Maybe we count by 5s. 5, 10, 20, 30, and 0.4. So make sure you label these as relative frequency. Okay, so for the histogram, our first one is 33. Leave a little space, then you start it. The next one is 37. It touches it. 22. 6. Nothing. And 2. there's your histogram. Okay, then we can do a frequency polygon. It's the one in the middle. The frequency polygon uses midpoints along the bottom. So we should look at what our midpoints are. So if we look back here, our first midpoint would be what is in the middle of 50,000 and 99,999. And that would be 79,999. So I'm going to do midpoints over here. So the first midpoint was 79,999. If I add 100,000 and 149,999 together and divide by 2, I get 129,999. Again, these should be 50,000 apart. So I can find the next one, 179,999, 229,999, 279,999, 329,999. And these are all 0.5s because we were dividing by 2 and it was an odd number. So they're all 0.5s. Those are the values that we're going to put on the horizontal of the frequency polygon. Remember, you do have to have one before and one after. So this first one is what was the first one? Oh, subtract 50, so it'll be 29,000. 29,999.5, 129,999.5, 130. No, that's a 119. That's a 119. No, wait. Yeah, 119. 129. Okay. What? Oh, there it is. 79, then 129. Yeah, I was right. Why was I second guessing myself? 129, 139, 1. What in my brain? 129. Why? My brain is just. Come on, Yonks. Wake up. 229,999.5 and 329,999. It's just the numbers. They're ginormous. All right, relative frequencies. 0.10, 0.20, 0.30, 0.40. Relative frequency. Then we have dollars on the bottom. And then we have a dot that starts on the graph and one that ends on the graph. And then we do our relative frequencies. 0.33, and then 37, and then 22, and then 6, and then nothing, and then 0.02, and then back down. So here's our frequency polygon. Lovely straight lines, totally connecting each of the dots. Frequency polygon. Then we have an ogive. Nice thing about once you get to the ogive is you can just kind of copy what you labeled the bottom with. 49, 149, 249, 349, 149, 9.5. No, regular 49. Man. And then 149, 9.5. 249, 999. 349, 999. And then remember that an ogive is cumulative frequencies. So we need to add to 100% or 1. So counting by tens is perfect. So this is 10, 20, 50, 70, 80, 90, 100, or 1. Okay, so we need cumulative frequencies. So let's just put them over here. Cumulative frequencies. Remember, the first one's always 0. Then we add the next one, which is 0.33 on, so 0.33. Then we add the next one on, which is 37, so we get 0.70. Add the next one on, which is 22, to get 0.92. Add the next one on, which is 0.06, to get 0.98. Add the next one on, which is 0, to stay the same. And add the last one on, 0.02, to get 1. So those are the values that we're going to plot on the vertical. Oh, I guess we should say that this is the cumulative relative frequency. Okay, so the first one is 0. The next one is 0.33. Then shoots all the way up to 0.70. Then it goes up to 0.92. And then up to 98, and then it stays 98, and then it goes up to 1. All right. That was super fun. Okay, so that's how to draw a histogram, frequency polygon, and ogive with really complicated data. Let's answer some questions. What questions could be answered more easily by looking at the histogram rather than the listing of home prices? Well, a histogram gives the ranges and the counts in each. We can also talk about how data is distributed using a histogram. So we can say a histogram gives price ranges and the counts in each. We can also look at how the distribution or how the data is distributed. Look at how the data is distributed. Number 2, what different questions could be answered more easily by looking at the frequency polygon rather than the listing of the home prices? Well, a frequency polygon can show you where the increases or decreases are in the data. So a frequency polygon shows increases and decreases in the data. Number 3, what different questions could be answered more easily by looking at the cumulative frequency polygon rather than the listing of home prices? And remember that a cumulative frequency polygon shows the number of homes that are sold at or below a given price. So we'll call it an ogive for writing's sake. An ogive shows the number of homes sold at or below a given price. Are there any extremely large or extremely small data values compared to the other data values? I would say there would be one extreme data value or possible outlier, and that would be that really high value that made that last bar graph what it was, which was that maximum 321,550. So we can say the house sold as 321,550 is an extreme value. Which graph displays this extreme the best? Well, if you look at the three pictures, I can clearly see a gap in the data right here. And so the histogram shows it best. So we can say the histogram displays the outlier and shows a gap in the data. And finally, is the distribution skewed? And the answer is yes, to the right. If I were to look at the frequency polygon, that's where I'm going to see that right tail that's going to taper off. So we can say yes, it is positively, which is to the right, skewed. You can also say or right skewed. Okay, that's the end of section 2.2. If you have any questions, please let me know. And as always, keep calm and keep trucking.